So we saw some connections between auctions. We saw a pairwise connection between the English auction and the second price auction. We saw a connection between the Dutch auction and the first price seal bid auction. And the question is, are there any general results on auctions that we can describe? We'll describe two general results from auction theory. The one of them goes by the name of the revelation principle, and the other goes by the revenue equivalence theorem. They both are rather surprising when at first encountered. The one becomes a little more or less surprising once you explain it, and the other remains still somewhat mysterious. Let's start with the revelation principle. So suppose we are, as we've discussed mostly until now, in the independent private value setting. Let us define a direct mechanism to be really a sealed bid auction where each agent has their type, their value for the good, and we're talking about a specific single good at this point. And all they can do is declare a type. If in equilibrium, every agent has an incentive to declare truthfully, then we'll call that direct mechanism truthful. The revelation principle says the following. You could have an arbitrarily complicated auction. It could be a very complicated indirect auction where you make some declaration and then others, maybe an ascending price auction, what have you. It could even be a direct mechanism, but not necessarily a truthful one. For example, a first price auction. The theorem says you could take that mechanism and give a mechanism that essentially is equivalent, that is direct and truthful. Now that's very surprising. How could you take any arbitrary mechanism and turn it into the straitjacket of truthful direct mechanism? But the answer is, like with many magic tricks, somewhat unglamorous. Really what you do is you take this very complicated mechanism, the very complicated strategies, and fold those into the mechanism itself. And sometimes we say colloquially, we have the mechanism lie on your behalf. It's probably best understood pictorially. Let's assume we have some mechanism, again, could be direct or indirect, and if it's direct could be truthful or not truthful. When in this mechanism, when you have a certain type theta, then you have some strategy associated with this type, again, potentially a very complicated strategy. Now consider another mechanism in which the original mechanism is folded into as is your original strategy. So that if you have a type theta, you can not only declare it, you can declare it truthfully or not truthfully, but this is a direct mechanism. You can only reveal a type and declare a type. And what the mechanism then would do is take your declared type and apply what was your original strategy to that declared type. So in that sense, if you were to lie about your type, the mechanism would do the lying for you. And now to simply mimic the original mechanism on this mimicked strategy. Now intuitively, we see that indeed it's in your interest to declare truthfully because the mechanism is doing your bidding on your behalf, so you really want to give it the correct information to do the correct bidding for you. This, at the abstract level, is very sensible, but you can really apply it very directly. Now let's look again at the first price auction. Again, the independent private value, and let's assume that all the values are distributed identically from this interval of 0 to 100. We already know that in this first price auction, which is not truthful, in a symmetric equilibrium, all bidders will shave a little bit from their true value, and if your value is x, you will bid n minus 1 over n from x, where n is the number of bidders. Well, now consider another sealed bid auction. It's a non-standard sealed bid auction, but in this auction, what happens, everybody bids a value, and And what the mechanism does is simply takes that value, multiplies it by n minus 1 over n, and then submits that modified bid to a first price sealed bid auction. Well, now in equilibrium, all agents will bid truthfully. For the same reason, the analysis is the same as the analysis in the first price auction. So this is an example of the revelation principle in action. And as we said before, once you think about it, it's perhaps a little less surprising than it was when you first heard about it. The second general results on auctions is less straightforward and has some practical ramification. It's called the revenue equivalence. So suppose you have an item to sell, you want to sell your camera, and you have the luxury of choosing which auction type to use. Which one should you use? In particular, should you use the first price or the second price auction, which will, on an expected basis, give you the highest revenue? So again, let's think about it. Just remember the setting. We have n bidders out there bidding for your item. I guess it now became a painting rather than a camera. And each bidder has a particular value, a type, theta sub I, and we're going to assume that these values are drawn uniformly from the 0 to 100 range. We already know what the equilibrium strategies are in the two auctions. We know that in the first price auctions, in equilibrium, agents will bid n minus 1 over n of their true value. And in the second price auction, they would bid truthfully. And in fact, it's a dominant strategy for them to do that. Given that, what can we say about the expected payments that we're trying to maximize? We know that in the first price auctions will be simply the maximum over all types, theta sub I of times n minus 1 over n, whereas in the second price auction, it will simply be the second price auction. Whereas in the second price auction, it will simply be the second highest value, since that also will be the second highest bid. So looking at the first price auction first, we have this quantity, which is going to be the revenue in the auction. And in order to find what it is in expectation, since n minus 1 over n is a constant, we only need to find the expectation of this quantity. Well, the expectation of this quantity, if we reach out to basic probability theory, we have here n draws from n independent draws from the uniform distribution between 0 and 100, and we're looking for the first order statistic, and that simply is the maximum 100 times n over n plus 1. So this will be the expected highest value, and if we now plug in this expression into this expression, we'll get the expected revenue. And we'll have that this n cancels out with this n, and therefore the expected highest revenue is simply 100 times n minus 1 over n plus 1. This is the expected revenue in the first price auction. Now let's do the same for the second price auction, and here it's even more direct. Here we are looking for the expected second highest value, since that will be also the bid, that will be also the payment that will be paid by the highest bidder. And here again we reach into basic probability theory. Again, n draws from independent draws from the uniform distribution, and we're looking at the second order statistic. In this case, we're looking for the second highest bid, and in this case, we have that the second highest second order statistic is n minus 1 over n plus 1. So something interesting happened here. This is the revenue of the second price auction, right? Because the revenue of the auction is exactly the second highest bid. It happens to be exactly the revenue of the first price auction. So did we just get lucky? Is it completely coincidental that these two auctions fetch you the same price? And the answer is no. This is what the revenue equivalence theorem tells us. The theorem, which was in a limited form, was proved by William Vickrey in 1961, and then in a generalized form by Roger Meisman 20 years later, both Nobel Prize winners. The theorem says the following. When we have an independent prices value with for a single good auction, if there are two conditions that are satisfied for an auction, namely, the first one is it's efficient. In economics, efficiency means that in this setting, the person with the highest value for the item gets it in the auction. Not necessarily the highest bidder, but the person with the true highest value. The second condition says that if somebody has zero value for this item, they shouldn't pay anything in this auction. All auctions that satisfy these two conditions have the same expected revenue. We now see that it's no accident that the first price and the second price auction have the same expected revenue because they satisfy these conditions, as do the Dutch and the English auction. And so all these auctions have in expectation the same revenue. This is the revenue equivalence theorem.